Hi, I'm Yuval. I'm working on the Redis Gateway in IBM. And well, this project was done as a part of the Connect program between Red Hat and Reichman University in Israel. And so many thanks to Liav and Omer. They were the students that actually did this work. Okay, so why do we need some help with the client-side geo-replication? Well, multi-site replication is hard. So I guess, show of hands, which one of you did multi-site setup in your clusters? Okay, which one of you thinks it's a complex system that has issues sometime? Okay, well, this is not new. There were talks about that, and this is quite reasonable. It's a difficult problem to solve. The whole idea about geo-replication, geo-redundancy is that you have two separate sites and two different geographies, so networking issues, performance issues with the backend, with the BI logs, with the data logs, or the communication between the clusters. Other things that can cause problems, dynamic resharding, and other issues that you might be aware of better than I even. One thing that is missing is to give control to the users. You need to know what's going on in your system. The system is highly asynchronous. The whole idea about geo-replication is asynchrony. And you need to understand when your objects are synced, where your data is synced, where your information is safe and sound. Currently, it's very difficult to achieve that. And what this project is really about is trying to give you, as the users, the control over your the replication system. So be able to know what's going on and react on that if you want to. So how do we do that? Well, the main idea is to have a very simple addition to the Redis Gateway. What we're adding to the Redis Gateway is new type of bucket notifications. And this is a specific notification to let you know when an object is safely synced to a zone. And by sending out those notifications to whatever mechanism that you have for notification, it could be Kafka, MQP, other mechanisms, then you have the information and you can act upon this information. How do we do that? Well, the first thing is you have to define the topic. This is very simple to any of you that knows bucket notification. It's pretty much the same process. You define a topic, which means where to send the notification to. You define that on the zone where you want to get notification where things are synced to. So let's say if we have zone A and zone B is the backup, then you do that on zone B. Then you define the notification and you have a new event type that we added. This is called the object synced create event. And you define notification in a bucket so we know to where to send the notifications to and when, which means when things are synced on a specific bucket. Well, then you upload the object. You upload the object to your main zone, let's say zone A. In this case, syncing is happening. Zone B knows about this object. Object is successfully synced, and then notification sent to whatever topic that you configured, let's say a Kafka topic in this case. And then you, the client, or the user needs to subscribe to this topic in the Kafka broker and get notification that things are synced. This is the overall process. Now, when you do that, then you can act upon that. You can, let's say, it could be something inside the client that you decide whether, oh, now I know that the main information is safely synced to a separate zone, then I can throw away the information. Or you can try and resend that. You can try to do some manual syncing. And I've had a chat before with somebody from CERN that they have a system to do like client-based syncing. This can help them. Or you can just report on that. You can have stats. You can have maybe some other external system that does all kind of mitigation and handling of problems if you find out that your objects are not synced. So I'm going to show you a quick demo. Well, it's pre-recorded, but still, just demonstrating whatever I explain now. Okay, so on the right-hand side, you see the zookeeper and then the Kafka broker. On the left-hand side, we're going to set up a cluster with 2 sites. That's going to take a while. Well, each of the sites is going to have one RGW It's all on the same machine, so you would distinguish between them that one RGW of site of zone A is listening on port 8101, and the RGW of zone B would listen on port 8201, and this is how you distinguish between the two zones, because it's just two RGWs running there. 1 second. The script will set up all multi-site nice on this one machine. Okay, so now we have this, this all set up. And the first thing that we're going to do is define the topic. Now, as I said, we're going to define the topic on zone B, because this is where we want to get notifications from. Credentials. And then you define the topic, and you define the topic to point to the Kafka broker that, luckily for us, runs on the same machine, so that's going to be a localhost Kafka broker. So the topic is created. Once the topic is created, the next thing we're going to do is we're going to define the notification. Again, you would see that we're sending that to port 8201, which is zone B, and we're going to create the notification there as well. The bucket is already created, and of course, metadata syncs the bucket information between the two zones. And you would see that the type of event that we're asking for the notification to be sent is this object synced create. This is a new type that we added to the bucket notification type system. So now that we have the topic, we have the notification, we would create a file, and we would like to upload the file. Of course, we're going to upload the file to zone A, which is listening on port 8101. On the right-hand side below, you would see that we have the Kafka consumer listening to the topic, because we want to get this information eventually there. So now we're going to upload the object to zone A, and object is uploaded, but not synced yet, because the syncing takes a while. It's, as I said, a highly asynchronous process. And in a couple of seconds, you would see the notification being sent to the Kafka broker from zone B, and from the Kafka broker to the Kafka consumer. So you would see that on the right-hand side. Now, let's say that I'm not cheating, and the object is indeed in both zones. I had a little bit of typo here, but anyways, I'm going to ls on the first zone. Of course, it's there because I uploaded the object there, but I'm going to also ls the bucket on the second zone, on 8201. And you will see that Kafka wasn't lying, and indeed, the object is safely synced to the other zone. Okay, 1 second. Okay. So, oops. Okay, what are the next steps that we have here? So, as I mentioned, you have to define the topics and notifications on the zone that you want to get the notifications from, zone B in our case. Now, if you have an active system, or you have more than two zones, that's going to be a bit cumbersome and inconvenient. So, what we need to add, and we need to add information syncing between the two zones. The same way that metadata is synced, those system objects that we're using to store the information about topics and notifications need to be synced as well. So this is something that we should add for the usability of the whole thing to be better. Currently, if you have multiple zones and you have all active, you have to go and configure those topics notification manually for each and every zone. So this is not ideal. We also want to add some more types of events. So as I said, we're going to get creation events, which is the most important events for the use case of making sure that your information is safe and sound, but mainly for completeness and maybe for other applications that we don't think about. We want to get deletion events synced, and deletion marker created, which is deletions on version bucket, event synced, so we need to add these. One of the students started to write also a wrapper around the Bodo3 Python library that kind of delivers the whole functionality end to end. So let's say that you have, you want to upload an object, but you want to be sure that not to return immediately, say object is in in the zone where they are uploaded, but I want to know exactly when it's synced to maybe more zones, maybe another zone, maybe more than one zone. So he started to write a library a Python library that wraps around Boda3 that allows you to do that in a nice way. It didn't never finish the work, but if you want to look at that and maybe finish that, then you can scan this QR code. This is the draft PR of the student. Other things that make sense is to write something that does stats and reporting based on those information, something that consumes those Kafka events, and write to Prometheus, let's say, something like that. And of course, a real data recovery mechanism that, based on some timeouts or some other logic, or maybe the importance of the data based on which buckets you're sending to or what kind of information you're sending to, may kind of manually kick in and do the syncing where they don't get notification that objects are synced for the bucket. So, the sky's the limit here, and really, as I said, help is needed on your end, because the whole idea is that we're giving you the information, but you need to take it and implement something that you find useful with it. Yeah, that's the talk. That was supposed to be a lightning talk, so I did it really quick, but I have time for questions if you want to. Yes. I'll just repeat the question. The question is, yeah, this is based on bucket notification. And the question was, are we going to get notification when the object is uploaded? Well,
you get the user information about the tenant information on as a part of notification, you only get this particular bucket and this object is uploaded. Do you get information about the user?
Okay, no. So the question, what kind of information do I get? Maybe I'm going to show that. It probably shows in the somewhere in the demo. So 1 second. Oops, I'll just pause that. So that's not all the information that you get, but you get quite a bit of information. You get the I think you get the tenant information. Well, it was cut, sorry. Yeah, well, we don't see that at the beginning. So this is like the S3 section. So I think you do get the tenant information. I don't think you get the user information, though.
When you say tenant information, does it mean access ID?
Oh, no. We won't put any credentials there. We might want to put like the tenant name. Yeah, and on top of that, there is the opaque data at the bottom. So when you configure the topic, if you want to add any of your personal, whatever you want to add there, then you can add that as opaque data. And we're going to append this opaque data to any notification that we're sending for this topic. So if you want some custom information to be sent over. I'm not sure that I don't think that we're sending the user. I don't remember. I can check the bucket notification documentation, but again, if something is missing, then you can add that manually there. If something is missing that actually makes sense, you can submit an enhancement tracker, and I'll be happy to add that.
The important part is the Ceph bucket notification mechanism should be able to send that.
Yes, it's the same mechanism. It's the same mechanism that does it, just a different event. We're not sending this when the information is uploaded. We're sending it when it's synced to the other side. Yes, thank you.
The new object sync notification, is that in sync with the S3 spec for bucket sync?
No, it's our own extension because it doesn't exist in AWS. But I don't know if you're aware, we have like at least if you write your code in Python, then the Boda3 or AWS CLI, doesn't matter, it's the same code base, they have like a way to extend their API. And as part of Ceph, we provide a couple of those extensions, especially around bucket notifications. So you take this YAML file, I think, and you put it somewhere in on your machine, and then whatever Bodo3 code that you write or AWS that you're running, AWS CLI command that you're running, are gonna just work with the extensions when you direct that, of course, to Ceph. Yes. Any other questions? Yes.
Now RGW has the ability to have Lua scripting to also subscribe to bucket notification in an uncertain event. Can this be achieved with the Lua scripting, or?
Okay, that's, the question is, can we do that in using custom Lua scripting that's wrote on the RGW? So currently, Lua scripting only works in the context of requests arriving to the RGW. So if you want to have some, strange, odd notifications sent based on requests, you can do that. You did that. But this is running in the context of object being synced. So that's a completely different context. And we don't have Lua script kind of hooks in the context of object syncing. We can add that. It's not too complex. That might be a good idea. And if we do that, then there'll be a possibility to do all kind of strange applications and notifications. Yeah. Thanks. Sorry? Yeah.
Most of the data centers, they have maintenance times where sometimes because of network upgrade or power outages, things like that. Does this know how to notify, like the second site, for example, have OpenShift or VMware that integrate with those systems to notify the consistent data, and they can basically, because with critical services, before you shut down one site, you need to verify that you have everything on the other side has to run. So that it integrates.
Yeah, the question whether this can be used to integrate with notifying the sites down. No, this is like, it's only send on the notifications when something is synced. I cannot, I don't think I can use that for site is down. If you build a system based on those notifications to try to identify problems, then maybe you can build such a system. Do you have time or are we out of? Okay, sorry. Thank you so much.